Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion will be part 18 of an ongoing series dealing with operating system deployment in Configuration Manager 2012. Today's session will be what I'm calling Advanced Scenarios 2. We had a session a couple back where we talked about a few other advanced scenarios. So in this one, we're kind of lumping together some items that we could do on their own, but we could also do these together. Some of these require more discussion than others, particularly the first two. So we'll just combine. So whenever we first started this series, I probably mentioned that I wasn't sure how many actual parts would be in the whole series, but somewhere around 25. It's probably going to be more around 22 or 23, especially now that I'm combining a couple of these in for trivia, in case it matters. So here we're going to talk about Multicast, Windows to Go, do a little bit of discussion about application deployment. Won't spend a lot of time there, but just to call it out. Talk about user device affinity. These bottom ones are going to be more or less along the lines of discussion points. And again, we'll spend most of our time on the first two. So let's jump in. So multicasting, a very interesting component that we can actually leverage in the imaging process. So first of all, what is multicasting? Well, essentially multicasting is the option that we can choose on distribution points that will allow a single stream of data broadcast from our distribution points to be consumed against multiple machines. So explain it this way. Let's say that we have an image that is 3 gigabytes in size, and we want to build 100 machines with that image. Without multicasting, we would be requiring that 3 gigabytes of data to move across the network 100 times. So 300 gigabytes of data across the network. And networks modern networks can usually handle that without much of a problem at all, but still it's a lot of data to move across the network. Whereas if we use multicasting, we send the stream of data one, maybe 2 times, maybe more, but generally 1 or 2 times, and that's all we need to build the 100 machines. So 3 to 6 gigabyte of data compared to 300 is quite a bandwidth savings on the network. And I say between 3 and 6, you can actually make it exactly 3. There's a couple of different ways we can use multicast, which I'll show you in a bit. So that's what we're really talking about, is basically optimizing the amount of data that we send across the network. Now there's things to understand about multicast and how it works, right? And the fact that it does not work in the entire imaging process. We'll talk about that in a minute, and I'll call that out in a second about what does work, when, and so on. You'll see it work in just a minute. All right. So the next question, to multicast, to not multicast, right? So it really is dependent upon your build scenario about whether you're really going to get much bang for the buck for multicasting. It also depends on the complexity of your setup. So the classic scenario that I think about where multicasting makes a ton of sense is if you have a single location or multiple locations that are dedicated to building machines. So I know of several customers that have what I call build centers, and that's where all of the devices for their corporate resources are built and then shipped out to their ultimate destination. In that kind of scenario, multicasting makes 100% sense, right? Because you expect to have lots of machines being built all at once, usually probably on a single network segment, but it might be a couple. And it's usually in just one build center that the imaging is happening. So that really allows multicast to shine, right? If you have resources spread geographically around, doing 2 or 3 systems in one location, 2 or 3 systems in another location, 2 or 3 systems in a third location, multicasting probably isn't worth the effort in terms of network configuration, in terms of return on investment, etc. But up to you, what particular scenarios you have and evaluating this, especially as we go through it. So in order to make multicasting work, what are the components? So it's probably easier for me to show you the components instead of just talk through them. So let me pull in the lab real quick, and then we'll walk through what the components are that are required. So here is my site server. It's also my distribution point in my lab, and so on. So there are a couple of components. So first, in Windows Features, I can launch that real quick. We need to have the WDS component. So as soon as this builds out, so whenever we think about WDS, typically what we're thinking about is Pixie boot. And that's not at all what we're talking about here. The WDS service is what enables multicast, but we don't have to have Pixie enabled at all. In fact, what we need is only the WDS transport server. Oops, move on. All we need is the WDS transport server to actually set this up and make it work, as you'll note right here. So this is on the roles page. I flip back and forth between a couple of them, but you see I actually have both. All you need is the transport server. I have both because I just installed it that way, but this component is really all you need. Okay. Beyond that, so once you have your WDS system installed and running, there's no configuration of WDS, by the way. Really all we need is the binaries in order to leverage them for the multicast service. So once we set that up, then there are certainly a couple of places that we need to go on the configuration manager structure to enable multicast. So one of them is our distribution point. So here I just have one. This is my cloud-based one. So one that is on-prem, so to speak. So if you go to Properties and look at the Multicast tab, it's just simply a matter of turning it on, deciding what multicast connection count will be, right? And then you very likely may need to configure these settings, but I did not. I just turned it on. I'm using these settings as is in a build center. You may very well be able to get away with using these settings as is, right? And then the other configuration option is maximum clients, this thing called scheduled multicast. So there's actually two kinds of multicasting to talk about, and this kind of illustrates it. There's the concept of what's known as autocast. So autocast is kind of what happens that supports that scenario where I said you might need 3 to 6 gig of broadcast in order to build 100 machines with that 3 gig WIM. Or you might just need 3 gigs. So let me explain. So if you have autocast turned on, machines will run through the imaging process, task sequencing, and they will do everything the way they normally do, meaning that when it comes time to load the image, they will simply look for that image, and since it's flagged for multicast, look for it on a multicast enabled distribution point, and as soon as they find it, they start running, right? So if you start machine A at 1 p.m., then at 1 p.m. it's going to join the multicast stream, and that multicast begins. If machine B, you boot up right behind it at 1:02, it joins the multicast stream, then it will pick up wherever it is in the multicast stream and begin loading. Machine C, you load at 1:05, and it joins the multicast stream at 1:05 and begins building. So the result of it is machine A is going to be able to consume all 3 gigabyte of the image download in one pass. But machine B is going to be 2 minutes behind. It did not get the first 2 minutes of the install. And machine C didn't get the first 5 minutes. So we will continue on. Machine B will continue on through the stream, but whenever it gets to the end, loop back around and get the first 2 minutes again. Machine C will continue on through the stream, loop back around, get the first 5 minutes again, and then we're good, right? So the point is, with autocast, while it is a wonderful option, it allows network load to go down, it's not as good as scheduled multicast. So a scheduled multicast, and I'll show you both. With scheduled multicast, you have the ability to turn on machines, and this is one I like really for a build center, turn on machines, boot them up, get them through the task sequence to a point where multicasting is about to start, and those machines pause at that moment based on the settings you have here to wait for the other machines that might be subscribing to that stream to join in so they can take advantage all at once. right? Again, easiest way to see is probably to see it, so I'll show that to you in just a minute, but you do need the distribution point enabled for multicast. The other thing that you need is content enabled for multicast. And so if I come over here and look at my software library, there's really two things that we can enable for content, certainly operating system images. So here's my image, and if you go to properties on the image and distribution settings, notice that this package can be transferred via multicast and the parenthesis of Windows PE only. So this is a good thing to note. Multicast only works in Windows PE only, or it only works in Windows PE. So this is for sure what you're going to want to enable multicasting for, because most of the time this is your biggest component of imaging, right? You can configure an image to only be available by multicast if you choose to, and you have encryption controls as well, but if you want to support multicasting, at the very least, this has to be turned on. Another place that you can actually enable multicasting would be driver packages, which I don't have any installed in this particular lab. The other place would be packages, right? So we'll go to the properties of this, one I've got coming up in a second discussion about Windows to Go, and enable multicasting here. So packages can be set that way as well. Most people, the mind understands the image part, and so you can play with the packages if you want, but at least we know where this thing can work. And lastly, not strictly a requirement of multicasting to enable multicasting, but certainly a requirement to make use of multicasting the way you would expect, is back under administration, making sure, like we would anyway, our boundary groups are configured well. So in other words, if you have a build center, and you want that build center to only go to a certain distribution point to pull content, then you need to make sure your boundary groups are configured in such a way that when those machines request content, they do talk to the multicast system, multicast DP. So if you have 10 or 12 DPs, only 2 or 3 of them in the build centers are enabled for multicast. You don't want those systems to go elsewhere, otherwise multicasting will not be realized, right? So boundary groups, really important to have in order to control, again, like anything, what distribution points systems go to. Okay, and also a part that I really can't show you here because it's my lab, but if you do have any networking issues, making sure that those are properly identified, build lab probably won't have much struggle there. So let's actually walk through a demo of this then and show how this works. So what I'm going to do, I did, just to confirm though, I did only set up the distribution point for AutoCast at this stage. So let me just confirm that took, and I'm not dreaming. Multicast, okay, so I did not hit apply. That's what I was afraid of. So hit apply. Now the distribution point is configured for AutoCast. So what that means is that these machines, as they boot up, will join the stream in progress. So I'm just going to go ahead and load this one, let it get going, and I'll load another system, and we'll do 3 of them here. All right, so that's actually starting up, so I will go ahead and start this one as well. All right, and let that have a little bit of time to get going, and go back to this one, click next. So I'm going to start loading this image. Off we go. I'm going to pull a third one in here, and we will kick it off as well. All right, so letting that start up. Now this one's running. So we'll go grab the same task sequence, if you will, image, and start running it. So off we go. All right, and then we'll wait on the third one, and we'll start it off. I didn't get there fast enough. All right, let me boot from CD. Off we go. And we'll let that go. So let's make some adjustments here. So I'm partitioning and doing that. Remember, the multicast only works for image deployment. So notice I'm on the apply operating system. I'm opening a multicast session right here. Okay, and then we'll let this other one catch up. So here's this one next. Off we go. So this one is catching up. and we'll just watch for a minute. So now we should start this one pretty quick here. So now we're applying operating system, opening multicast session, but this one's already started. This one's off and running. This one is just trying to get the stream at whatever point in which it's at, right? So we'll give that a second and let this one progress. Okay, downloading. So this one's a little bit behind. This one the same, just one block, but I would expect to see the second block show up here before the second block does here, and then hopefully we'll have the second block in both cases before here. Maybe. We'll see. Okay, let this kick along. Okay, 2 blocks, 1 block, and then we'll have 1 block here, and then we'll just let it proceed from here. Once it starts. Okay, so now all 3 of these are in progress. So what I'm going to do is just pause the recording so that we can let this progress, and then we'll watch them all finish up. And just as evidence of the fact that they all finish up at different paces, but yet they've all done this through multicast, which is the definition of the autocast configuration that we've input here. All right, so we've downloaded the image most of the way now. You can see that all 3 are still in progress. And one thing to call out real quick, so it looks like we're downloading http:// we are, but it looks like almost like we're not using multicast. Notice this, using M, so that is multicast. It's just too long to string off the screen. And so we should see this one end and continue, this one end and then continue a little bit behind it. So behind the scenes, we're actually looping back and grabbing more of the stream. So I'll let this run on this particular machine while it runs, and we'll watch it finish up above. I want to show you in the logs something here. Move this off to the side for a moment. So in terms of troubleshooting, this is how it looks different. Let me look at it. All right. So you see it's running. The first 2 above are still going. The last one that I'm on right now is still downloading, but should catch up soon. So I'm just going to open this up. So let me search for multicast. The first hit won't matter that much. In fact, if I cancel this and just... Here, let me do it again. All right, that's just a string of data that we're feeding in. Here's the multicast server. But if we go down, content location, MCS : we're multicasting. We're going to scroll down again. Locations, multicast equals 1, so it's enabled. Multicast, retry, delay, all these settings we're getting. Trying multicast server, performing multicast download, and so on. Initializing multicast download. And we keep going, multicast provider. So we are definitely using multicast. You can see it all over the logs here, the multicast host, multicast server, remote path, off we go, right? So you can definitely track this in the logs. Now, let me turn this off. And what I want to do is go back into the site server and enable scheduled multicast and show you what that looks like. So switching back to the site server here. If I go back to my distribution point, go to Properties, and this time enable Scheduled Multicast. So I'm either going to wait 1 minute before I start the stream, or can wait until at least 3 machines have joined the stream to continue. So let me go implement that. So if I go turn these back on, we'll let them start. All right, let this start to load. Turn this one on too. Okay, good enough. And then turn this one on. Oops. There we go. Turn this one on. So I'm going to let these all get to the same screen before I start, just for ease of use more than anything else. All right. So let me go ahead forward in here. This just identifies the task sequence is still available. Go ahead forward in here. And then shortly go ahead forward in here. All right, so I'm going to start running all these, but I'm going to intentionally start them about 5 seconds apart. So we'll start this one. Let it go. 1001, 2, 3, 4, 5 or so. We'll start this one. 1, 2, 3, 4, 5 or so delay, and we'll start this one. All right, now let's pull this up so we can actually see all of these simultaneously. We're running here, partitioning, and in just a second, this one will be at the same place, hopefully. So applying operating system. Notice what it's going to do now. It's going to wait for other systems to join in. So we have a 1 minute threshold, or we have a 3 system joined in threshold. And so either we're going to start in a minute, or we're going to start after we have all 3. So this one goes into a wait state. So now, since all 3 of these are in a wait state, we should proceed without having to wait for the entire minute. So let's just see how long until we actually recognize that. There we go. And now the multicast stream starts, right? So that's what scheduled multicast looks like. I can now pull these out of the way because we're done with those. But at least wanted to walk through and show you what you can expect, how it works, the options you have, and so on. Right? Okay. Let's shift over, talk about Windows to Go. So what is Windows to Go? Windows to Go is a feature that actually is capable of running on Windows 7, 8, 8.1, 10, whenever that ships. And basically what this is the ability to run a full PC on a USB stick. It's a process that allows you to essentially image a running operating system onto a USB stick. And the advantage would be, think about whenever folks travel these days and business trips and so on. The common practice is to take a laptop, or now take a tablet or a Surface or something like that with them, and that's probably not going to diminish in any great extent. But how cool would it be if instead of taking a tablet or a Surface, a laptop or a Surface device or a tablet or whatever with you, instead you could put in your pocket a USB stick, and then whenever you walk up to a PC, any PC really, and plug that USB stick in and reboot, it reboots into an operating system that is your working environment with all of your apps, with all of your settings and such, but now just running off of a USB stick. And that essentially is what Windows to Go is, right? And so, probably answered the question already about why use Windows to Go. Really, it's just another option to empower the user, to empower user flexibility, to work differently, maybe inside your organization. Maybe a situation exists where you might have someone traveling between sites, and instead of having to, again, lug things around, they can take the USB stick, and when they get to their destination, maybe there's a bank of computers that are available for them to plug into and use with Windows to Go, and that's an option people might choose to use, right? So the other thing that people sometimes wonder, I guess, about Windows to Go is security. So Windows to Go is Windows, and like you can secure Windows with BitLocker, you can secure Windows to Go with BitLocker as well, right? So enough on that, right? This is not intended to replace the full PC experience, but it's intended to give another option, okay? So all of that said, that's what Windows to Go is. The question on the table here is, how do we configure Windows to Go with Configuration Manager? Well, should probably say that there really is no specific requirement that you use Configuration Manager for Windows to Go. There are several ways you could actually set up a Windows to Go image manually by using the Windows to Go Creator. In fact, that's a tool that we're going to use as a part of this. Using PowerShell, you could do some Windows to Go configuration. DISM, you can do Windows to Go, and certainly Config Manager is an option as well, and that's what we're going to focus on here. So what are the requirements of actually setting up Windows to Go? Well, there's requirements that are specific to Windows to Go, and then there's requirements that are specific to Configuration Manager. In terms of Windows to Go itself, we certainly need to have a supported USB device, and there are multiple ones, and they're not just all USB sticks. There are some USB hard drives that you can use. In fact, I will use one of those as I move along. Right? We have to use Windows to Go Creator. There's also requirements for Config Manager, which is to use pre-staged media in order to build this out. So I'll show this to you, explain it to you a little bit more in the next slide because it's easier to visualize visually. And then finally a deployment task sequence, right? And then there is also the component OSD BitLocker underscore Windows to Go, which allows us through OSD to deploy BitLocker onto the Windows to Go media. So this is a diagram that I put together to try to illustrate this. I'll admit that it's hard to wrap your mind around until you do it, right? But we've talked about in previous sessions the pre-staged option. If you haven't watched that session, if you haven't gone through that session, probably not a bad thing to do in order to better understand this. But essentially, pre-staged is a mechanism that had its genesis in working with hardware OEMs, so the Dells, HPs, IBMs, Lenovo's of the world, right? So one of the options that we give you inside Configuration Manager is to leverage pre-staged media to essentially preload certain components of the imaging process onto a hard drive. So in the specific case, maybe an OEM, as they are putting together the machines that have been ordered, they will run this pre-staged process on the machines to pre-provision the operating system that ultimately will be loaded onto that machine, put all those files on the disk. So it's basically a time-saving kind of way you can do things, right? The requirement, though, is with pre-stage that you have that pre-staged task sequence, which will load, again, the WIM onto the drive, the WIM and any packages. So you would have a pre-staged task sequence that would do that, right? And that's all embedded, and I'll show it to you and explain it to you, right? All of that gets embedded into the WIM file that ultimately is created. And you would also have to have a deployment task sequence. So the point I'm trying to make here, and I'll highlight it a couple of times hopefully to make sure I communicate it well, is that the WIM, the content that you would actually pre-provision onto the disk with the pre-staged process has to be the WIM and the content that the ultimate deployment task sequence will use. And as that deployment task sequence runs, it will recognize the content is already present and then just pass by trying to re-download it and provision it unless there's a specific need to that we recognize that something's wrong or versions mismatch or whatever, right? Long-winded explanation of what pre-staged does. So with pre-staged, basically we're, in this example, going to use a Windows 8.1 WIM that is targeted to Windows to Go, that I'm going to use and want to meet. By my meaning targeted, that means that's the one I want to actually put on my Windows to Go USB device. There are three things that are part of the pre-staged media that are critical here. One is SMSTS preferred advert ID. Right, that is a variable in Configuration Manager that is useful outside of this scenario. It's actually a really cool piece of this. You can use this variable in the pre-start command to actually specify what task sequence deployment you want to run. And the reason this is critical here is the typical flow or the flow of pre-staged is that you would run pre-staged, and then that process basically unpacks all the content, puts it on the drive, it's done. And then when you reboot the computer, it comes up in Windows PE, and in Windows PE, boot media essentially, it will stop and ask, what task sequence do you want to run? Well, the task sequence that you select has to be the one that matches the content that was laid onto the hard drive. If it's not, the content on the hard drive is just overwritten. It's just like a normal image. Here, by specifying the particular deployment ID, you can eliminate all mistakes, and the user doesn't have to stop and choose anything. The system just automatically goes and finds that ID and runs it, right? All right. Another variable, OSD BitLocker pin. So if we're going to provision BitLocker, which you should, on Windows to Go, then we need to specify a pin. That's something we can do by variable. And then SMSTS UDA users, if you want to use that, right? So this is a user device affinity variable, and we can talk about that more as we get to user device affinity. We will. But those three are interesting in this scenario. This one, critical, right? So we're going to create our pre-staged media. I'll go through that in just a minute whenever I show you kind of how to set this up. And then we're going to create and deploy a Windows to Go creator package. So we actually are going to load the pre-staged media in this case with Windows to Go creator. So typically with pre-staged media, in order to deploy that pre-staged media, we will actually create a task sequence that will do it. In this case, that's not how we're going to do it. We're instead going to use the Windows to Go creator tool, and you'll see in that tool where I specify the WIM file. Again, I'll walk through this. Finally, create a Windows to Go BitLocker package and an update task sequence so that we have both of them available. So the BitLocker package is essentially a reference to the source files that we want to use to configure BitLocker. And then the task sequence is going to actually go through the actual deployment. So this preloads the content. This actually deploys Windows like we would a normal task sequence, right, to get it fully up and running. There is one command that we add in just after the Windows set up Windows and Configuration Manager step. And once we're all done with that, we're going to deploy the Windows to Go package and task sequence to a machine, okay, that we want to create Windows to Go. User selects to run the Windows to Go creator. USB is pre-staged. Ultimately, the system's rebooted. The install finishes. So I can't, in this lab, really show you all the way through easily. Otherwise, I would disrupt what I'm actually doing here because my system would reboot. And the other challenge is I'm using virtual machines. And virtual machines have challenges with USB. But let me show you as far as I can take it, right? So the first thing that's really interesting, regardless, this is not a Windows to Go thing, but it's just an interesting piece to understand. In Hyper-V, we initially did not support USB at all, right? So there was no way to tap into a USB disk, USB connected device at all while you were in a virtual machine. Now we actually do. It does not enable the Windows to Go scenario, but it will allow us to pass through a USB attached device disk, in this case, to a virtual machine. So let me start by showing you that because it's interesting, and then we can go from there. So I'm going to go ahead and load up Hyper-V Manager. All right, and here I'm just going to connect to this machine, just a Windows to Go creator machine. That's just running, so I have it here, so I'm going to start it. It's easy to use. Right, so I'm just going to connect to this device. I'm just going to double click on it. Now, this only works through this kind of connection. Notice show options. If I go to local resources and tell us more, one of the things I have is drives. And one of the drives that I have in under here is this removable disk, which is a USB connected disk. Right? So if I hit connect now, it's going to bring up the system, but now it's going to bring it up with that USB drive connected. So if I log in and try to browse to it in Explorer, I will see it. Okay. So this is cool because I get to browse it and treat it like a normal disk. This is it's kind of in a halfway state because I'm going to use this disk for a Windows to Go demo in just a minute. But it's not cool for this in that this is not truly seen as a USB device, as you'll see in just a second. So I'm going to close this out. All right, I'm going to pull this off to the side for now. Pull this out of the way. All right, minimize and get rid of this. All right, cool. So now how do we go about actually configuring this in Configuration Manager? So let's show the various elements of this in the lab. All right, and so what I've got is I've got, like I mentioned, my let me go back to it. Oops, that pulled up the PowerPoint. Didn't mean to do that. Let me go back to the lab. there. All right, so first we have to create pre-staged media. So under our task sequence, if we create task sequence media, this is the option that I'm talking about. So what all this does, the only thing this does, is that it will create a WIM that we are then able to use to preload onto a hard disk. As mentioned, the typical way that we preload onto a hard disk is by using a task sequence as well. In fact, if you watch my previous session talking about pre-staged, that's what I do, is I will use a task sequence to preload that WIM onto the drive. That's not what we do here. Here we just use Windows to Go Creator, but regardless, the process of creating this initial WIM is exactly the same, right? So I'm going to use site-based media. I'm just going to call this test.wim because I'm not going to save it. I've already gone through the work of this, but just to show a couple of things. So this should be very familiar territory. This is unique, right? Here we have to specify what task sequence ultimately is going to be run by this. And this is not creating a hard link between the two. Basically, this is a discovery process to find out what all is on, what kind of content is required by that task sequence, and whether I want to detect dependencies or whatever, what all I want to preload, right? So here will be just boot image and different things that are needed by this. This is going to be to facilitate loading back into Windows PE after we boot the machine that has been pre-staged for the first time. All right, and then next. Okay, and do I want to select application content that I want to add, right? So this would be any other things that might be in view that I want to add. Any package content that I want to add in preload, driver package content, whatever, any distribution points that have all this enabled. All right, and then I'm finally to the screen. This is the one that's really the most important for the Windows to Go scenario, and this is where I would add my variables, the ones I referenced earlier, right? The variables that point back to the advert ID of the ultimate task sequence for deployment, the SMSTS preferred advert ID, OSD BitLocker, SMS TS UDA users, whatever, right? So this is the process I go through. If I click next, I'm going to go through creating that pre-staged media, a WIM file. So, but if you notice, I've already got, actually I didn't import it, sorry, I've actually already got the pre-staged media on the drive. So if I go to my package source folder, Windows to Go demo, here is the pre-staged WIM that I created. So I did not import it into ConfigMgr. That is a normal step for pre-staged. Why? Because then you're going to use a task sequence to deploy it, and it needs to be in ConfigMgr for that purpose. Here, we're not going to use a task sequence to deploy it. We're just going to use Windows to Go Creator, which is in this folder. Okay. So then the question comes, okay, how do you, or what is the source for Windows to Go Creator? Where do you get it? And the answer is probably not the first place you would look, at least not the first place I looked. It's actually on the disk, the ConfigMgr install folders, OSD, and then Tools, and then Windows to Go. Here's our Windows to Go Creator. Here's our BitLocker utility we need for using this with Configuration Manager. Okay, and then finally, after all of this, we're going to have a deployment task sequence to actually do the finalization of the image once we reboot onto that USB disk. So this is a standard, a very standard task sequence. Everything here should be familiar. You know, there's a disable BitLocker here. There's a restart. I mean, all of this should be very familiar. Pre-provision BitLocker. You know, all of it is normal. Here I'm applying an operating system, the one that I have preloaded, Windows settings, network drivers, all these things. The only thing that I have added is this, right? And so this is a specific run command line step that is needed to go ahead and push out BitLocker and configure BitLocker on this USB stick as we finish imaging it, right? And then once we've pre-provisioned it, we enable it. Okay, so this is unique for what this is for Windows to Go. The other thing I have is I have this Windows To Go Creator package, okay? And the package has a program, because I deploy this thing, to tell me how to run Windows To Go Creator. And so you see the path in my source directory, Windows To Go Creator. Here is where I'm specifying the WIM that I want to load, and Windows To Go Creator will put it out there, enable boot, so I don't have to actually stop and tell it go ahead and boot from USB, right? And then beyond that, I have my BitLocker for Windows To Go. This is just a package to provide access to the source files, is all this is, right? Okay, enough about that. Let's actually see this work. So if I pull back in my machine, let me take this off of the view so it's bigger, or I can get it all on one screen. If I actually go into here, I should have the task sequence and stuff already deployed. So we'll run it. Software Center. And in fact, I do have, here's the task sequence. I've already run this before, and so I'll run it again. And you'll see that I fail right real quick in being able to leverage this. It's not that it fails to run. It does run. It's just it can't find a USB disk. Even though I've redirected a USB drive into this VM, can't find it. And so this kind of stymies me being able to demonstrate this on a virtual machine. But here's what I can do. I've actually got Windows To Go source files over here on another monitor that I can try to run. And I'll take it a little bit further. I can't take it all the way through, but I'll take it a little bit further. So this time I'm just going to run the source, run through this manually, right? Windows To Go Creator. Let's see. Well, I'll just go over here. You know what? It helps if I'm actually using the command prompt on my other system. I do that sometimes. All right. Here, desktop. All right. And then I'm going to go into Creator. And I move the pre-staged WIM into here just for convenience. Windows To Go Creator /WIM : Win To Go Pre-staged. All right, and let me just pull this up real quick in my Explorer view. I have got this USB disk actually staged over here. I've got it kind of hidden. Let me show you in disk management that this actually takes it offline. Whenever I redirect and allow sharing like I did to my virtual machine, then it takes that disk and kind of marks it offline. It's right here. So what I need to do is go into my virtual machine and basically disassociate this. So I'm going to turn it off. Easiest way to probably disassociate. All right, and then we'll go ahead and refresh this for a minute, take a second, and then it'll come back. All right, so it's showing up here now as my new volume, right? Drive E. So now if I run this command line, it's going to let me specify drive E because it found it. It's local, and I can start to build it. Now, I'll show you as far as I can how this looks, and then I have to stop it so it doesn't get all the way through. But here we go. So it's preparing it. I've got drive E, and should have a couple of things done to it here in just a second as we expand files, applying Windows image. So we're starting to notice I've got drive F now, so it's actually splits the partition. I'm opening up the WIM, getting ready, and near the end I will go ahead and reboot and the build process will continue. So I don't want to do that, otherwise it would kind of get in the way of what we're talking about here, but at least that's as far in the process as I can go right at the moment. So let me pull the lab back out of the way and we'll continue. All right, so now kind of shifting more to some discussion time as we go through a couple of other topics. So the whole idea of deploying applications or deploying content, I probably should say, during task sequencing, right? Certainly something that is important to do during task sequencing, loading packages, changing settings, doing that kind of thing. And there are really 4 ways that we can do it, maybe more. PowerShell probably I should add to the list, and so on. That's kind of a run command line option. One, very common one, because it was the only real choice for content deployment in 2007, was packages, right? So people still use packages. Packages are very, very convenient because you can actually, like I did with the Windows To Go Creator BitLocker files, I can create packages that simply point to content without actually having to deploy that content or have programs for that content, so that we can access it in a very easy way during the task sequence. Same example would apply for the client package, right? Or the USMT source files. There's no program that's required because the task sequence knows how to go into the package and get the content. It just needs to be available to the task sequence. And packages work really well. So if you're trying to use a package to deploy a batch file, or you're trying to use a package to deploy an executable MSI or whatever you want, it works really, really well in task sequencing, right? Applications do too. Right? Applications do have a few challenges that you can run into. I won't go through the laundry list here, just highlight the fact that applications work really well inside task sequencing. 2, it has the added advantage of being able to track dependencies and supersedence and such, and that's one of the places where it's a little bit odd. Inside of task sequence, expectations are different than you might normally have. But they work well, right? So test and make sure. Applications are more complex, though, than packages, depending if you build out all the logic with supersedence and dependencies and deployment logic or detection logic and things, right? So use your best judgment. At V, you can certainly deploy during task sequencing, and then finally run command line. Right, run command line is a very easy one to use. You can run PowerShell scripts, you can run batch files, you can run really whatever you want to. Right, so I just highlight these all as deployment mechanisms. Actually, I thought about pulling this slide out because to really go into all the details of this would take more time than what we have here. But just to call out that these are the various methods that you can use. Your mileage may vary with each one, so use your own judgment what is best, right? The one thing that I prefer not to see is to have duplication of effort recreating packages when you could just use applications, because somehow applications might not be meeting your expectations, right? So if that's the case, really evaluate what's going on versus just duplicating your work. All right, so what about this thing called user device affinity, right? This is actually an interesting piece, okay? And I'll show you a couple of things on this in a minute. So how does user device affinity play with imaging? Because one of the things about imaging is you cannot deploy an image task sequence, or any task sequence really, to users. Right? User device affinity, by the name, infers that you're putting the user in scope, and you for sure are. But the way we do this with task sequencing is a little bit different. So what are the benefits, right? Well, first, with user device affinity, you're going to be able to create a user and device relationship during the imaging process. So for example, if you know that we're building this, you're building a particular device for Betty, right? Then you want perhaps to be able to say to that device that it is being built for Betty, and so make this customized for Betty, right? Well, there's ways that you can do that in other imaging solutions, like MDT has the MDT database to help associate certain things, especially applications, with Betty and preload those as a part of the imaging process. UDA support in task sequencing is the way we do it in OSD. Right? So at the very beginning, if we set this up, the very beginning of the task sequence process, really at the pre-start command level, we're going to put some logic in the process that will allow us to input the fact that Betty is the one ultimately that's going to run on this machine. Right? After that, we're going to construct our task sequence in a way that recognizes we're going to use UDA. Now, let me say, besides associating the user, what's the real benefit of using UDA, right? One of it, really, what we're trying to solve is pre-loading applications and things that are needed by the end user into a task sequence without having to configure the task sequence specifically for the individual user. Meaning we don't have to account for every single application or package or thing that the user might need. We're going to use UDA to define those, right? What we are going to do is any application that requires user state restore. So if you're using user state restore, there will be those applications that you might want to make sure are present. So whenever the user state restore phase comes along, those applications are present. We can restore the user state onto the system and have those applications configured like normal. So besides that, though, there really is no configuration required in the task sequence for applications, right? After that, we're going to configure a variable, SMSTS assign user mode variable in the task sequence. Now, all that does is it essentially is the same thing as configuring it in the GUI, right? So let me show you the GUI so you know what I'm talking about. So if we go back into the lab and go into probably the easiest is to go into the properties of Pixie, because that's where you'll see it. You'll see it on the boot media. Actually, we'll do boot media. I'm here, so why not? So create boot media, and I'm going to go through and create bootable media. One of the first things that I'm asked is where to put it, right? So I'll just say test.iso. Next. All right, and here, UDA device affinity. So by default, do not. Or you have allow user device affinity with administrator approval, or just do it automatically. These are the three options that you can also set with the variable that I mentioned, right? You have that option for Pixie as well if you want to configure it there. Right. All right, and then once we do that, we're going to do a couple of other things. One is configure our pre-start command to collect our user information. So there's a couple of ways you can do it. Ultimately, you're going to want to populate SMSTS UDA users. That's the variable. You're going to assign the username, at least one. It could be multiple users, but at least one who will be primary for this device. And you could use the pre-start command to pop up a GUI, an HTA or something that the user can interact with and fill out. Or if there's another way, maybe you have a master list somewhere, SharePoint farm where you have the information, or some other place, database, whatever, that you know a device by a particular identifier is going to be going to another user, then you don't have to stop the task sequence. You don't have to let the user be involved at all. You just write your little script to collect this information and store it in the variable in such a way that it goes to your location and just picks the information up and goes on, right? And then the configure primary user assignment is kind of the same thing here. I just showed it to you where you can decide. And then after you do all this, then the imaging operations will proceed with UDA support. Now, what does that mean? Imaging operations proceed with UDA support. Well, essentially, imaging will proceed normally. The only things that are different is that you do not configure every single application that you want that user to have in the task sequence. You certainly configure it, but what you do, the way you configure it is different. So by using UDA, you are saying, you are implying that you want to configure user-based targeting and support for application deployment in Config Manager. Well, if you have Betty in this case, and she's in a number of collections that have applications and things targeted to her, by setting the variable for Betty to be known by the task sequence, SMSTS UDA users, at the end of the task sequence, you won't even see it really. You can watch it in the logs. At the end of the task sequence, we will go into Config Manager and inventory all of the different applications that are applied to Betty, and we'll just load them on the fly, right, without any other configuration. So it's really taking the configuration of the applications or deployment of the applications out of the task sequence, except for those that require user state, and putting them into the system where they are anyway, and being able to take advantage of it. Right? So UDA is pretty cool if you're factoring the user into your deployments, for sure. Right? All right, and for awareness here, I've already said it, right? So this is, since we're offloading from the task sequence and putting it into Config Manager, where it is anyway, we're not going to see it happen as a step in the task sequence. You can watch it in the log, but it's going to maybe be a little bit more of a complexity to troubleshooting since we're not going to see applications install like we would. There's no individual steps for the task sequence, right? But still, a very worthwhile thing to investigate, solve some really unique problems as well. So that's UDA. All right, so a couple more things and then we're done, right? So I mentioned these last two things for just awareness, interest, discussion, right? So there is this concept that you could leverage that I call up-versioning a task sequence. So the discussion kind of goes this way, and I have a particular customer that falls into this scenario, and so it's an interesting thing to consider. So whenever we image, we know what that is. It's taking a machine and putting a new image on it and making it ready for the user, and off we go, purpose, whatever, and off we go, and we know how to do that, right? Well, what if you treat imaging kind of like you treat software development, which isn't a bad way to go with imaging, and that means that maybe each quarter you're doing your work to get ready for the next quarter, putting in any changes for the imaging, testing, getting ready, and then once you get done, that image goes live. So maybe you're doing the prep work in Q1, the images and such that you build for Q1 go live in Q2. So all throughout Q2, you're delivering version 2 of the image, right? And then throughout Q2, you're doing the prep work for Q3, but Q2 work is still going out. Q3, you shift over, and now Q3 images are going out. Q2 is retired. And you're building in for Q4, and then Q4 images go live, and 3 are retired. It's a pretty cool way to think about delivering software or delivering images, right? Here's the challenge. So what if you have systems that are around, and probably will be, for years in an environment? After you build them, they're around for years. And so in the meantime, you've progressed with your imaging process to build in new standards to the corporate image and so on. So the machines that you built with the Q2 image, while still workable, while still good, they are now out of date against the Q4 imaging process you're running. And if you were to compare what you've done differently between Q2 and Q4, probably the list of changes won't be huge, won't be massively significant. Maybe they will be, but they nonetheless are changes, right? So what if you were to, as a part of releasing a new operating system, so between Q2 and Q3, between Q3 and Q4, not only do you release the new image, you also release and prepare a delta task sequence. So this new task sequence would not be one that actually images anything. It's not going to require the system to be re-imaged. But what it will do is it will take the differences in configuration of that image between Q2 and Q3, Q3 and Q4, and kind of wrap them into a task sequence on its own that you can then deploy. So once you're at Q4, you can deploy a task sequence to up-level any Q2 systems to Q4, any Q3 systems to Q4, and it just becomes a part of your rolling imaging process. It's an extra value add that you can use to make sure systems stay up to date, even though they might not necessarily be fully re-imaged. Right, so that's essentially the concept. Hope that communicates. That kind of dovetails into the next part, the last discussion point, right? Using a task sequence for other than imaging purposes, right? OSD was built from the ground up for the purpose of deploying an image to an operating system. And there are lots and lots of people that use it for other than that, right? People, customers all over, will use task sequencing for unique deployment scenarios that really no other mechanism inside Configuration Manager can cover. The application model in 2012 is a really, really good step toward answering some of the scenarios that OSD kind of uniquely controls, like handling reboots and different things that you might need to do during the deployment of content, right? Ensuring it goes always in every single time in the same predictable way. OSD will do that. Applications generally will too, but there are some differences. The point of all this is Using a task sequence to deploy applications to run essentially non-imaging scenarios is not officially supported in 2012. Right? The product group really didn't intend for customers to use it, but there's been so much customer adoption of doing this that it's recognized as something that customers do. It's actually something the product group is, kind of trying to think through as of this recording. It's something that I don't advise my customers not to do if it solves certain scenarios for them. It's just something to be aware of. It's not officially supported, meaning it really wasn't tested because there was really no intention to do it. We do know there are some issues around it, right? Just a couple, and there could be more, right? Task sequences might stay in a running state. So if you look in Software Center for a non-imaging task sequence, it might actually continue to show like it's running even though it's not, right? Which can be more of a cosmetic irritant, but it's still kind of irritating. In some cases, you might have multiple TS manager threads. So I've seen systems that have 30 or 40 TS manager threads still open in the task list, and they're really not causing any harm except for the fact they consume system resources. And that's not good, right? So there are ways that you can actually mitigate these. So for the multiple task manager, TS manager threads, there's a compliance setting that you can kind of set up with a script to determine, are you in a situation where you have multiple threads, and then use some tools to go ahead and resume those threads. And that's important. Don't just cancel them, resume them. And the reason it kind of gets into that state is there's a handoff that kind of goes between threads that kind of gets out of sync or stalled, right? And there's other things as well. Certain applications deployed through a task sequence can just act differently than you really expect, right? So the best way is just be careful, right? Whenever you're doing this, make sure that the result that you're after is actually the one that you're getting delivered through this. Test it a lot, and just be aware, that you're kind of treading in territory that we didn't really consider as we were building it, right? Use it if you need it. Again, not discouraging you from doing that, but just use it like anything with the knowledge to be successful. And with that said, we'll wrap up the session here. The next session we'll be talking about Dart in Configuration Manager, how to use that, some of the advantages and such. So we'll wrap this one, and we will continue then.